Okay, so we are continuing. I ended my last video a little bit early. I needed to ask these questions, okay? So we're going to start off this video, which has still all the remaining topics that I've put on here. We're starting it off with these two questions. So we finished talking about standard deviation, how to calculate it by hand. We know the definition now. And here we have these concept questions, okay? So first, to start, can there exist a data set with a negative standard deviation and y? And then can there exist a data set with a standard deviation of 0? So I'm going to pause the video, and this is going to be a free response question. I need you to think about this. Make sure you say why. So I'm going to number this. This is going to be 1 and 2. You need to write these in your notes as well. 1 and 2, which you'll have a chance to do because I'm going to pause it and you can just copy them down. And then write your answer and type up your answer for me for 1 and for 2. So I'll go ahead and pause and let you do that. Okay, so let's talk about this. Can there exist a data set with a negative standard deviation? So the answer to this is no. Okay. If we think about the last video where we were talking about our data set, we had drawn the mean here. And if you think about it, every single distance from there has a positive length. And think about this. Like if I took a ruler, so here's a ruler, and I start measuring distances, like the distance of my finger, it will never be negative. There's no way to measure a negative on this ruler. So that's the idea. Deviations are distances and they can't be negative. If you think about it from a formula standpoint, which I had a lot of students in class do this, they said, well, it's always being squared, so it's impossible. But that's a little too, I mean, that's fine and it's true, but it's more important to know that a deviation is actually a distance, okay? And that makes it easier to understand why this is impossible. So we're gonna put no. We're gonna say deviations, we're going to say distances are always positive. Okay, so that's the answer to that. So write that in your notes, and hopefully you put no. You may not have had this reason, but hopefully that makes sense. Like if we think about it, if we're picturing the distances in our head from the mean, you know, that's what we're thinking, okay? All right, next, number 2. Can there exist a data set with a standard deviation of 0? So, is this possible? Yes, it is, okay? Yes, but there's only one specific condition. All data must be the same value. If all the data is the same, then that means it's the mean. The mean is that data. Like if everybody scored 100 on the test, what is the mean for the test? Well, it's 100. What's the median for the test? 100. The max, the min, 100, 100. Like everything is 100. Well, there is no deviation from that mean. There's no distance, so it would be 0. Okay, hopefully that makes sense. So the deviation would be 0. So this is entirely possible. And this is actually an important concept to keep in mind for this class. Besides that, everything is going to be positive. Okay, it could be a large distance, it could be a small distance. All right. So here, one final thought is this. If we want to make our deviation go up, we need to add data further away from the mean. If we want the deviation to go down, we need to add data close to the mean or exactly the mean. So like if I had a mean of 66 and I want it to go down, I would just put values that are close to 66, or the best way to do it is to just put values that are 66 in there to make it change, okay? So that's important. Now this is also that idea is going to play a role into the next idea, which is this. You're going to draw a line, and we're going to talk about choosing the appropriate measures of center and spread. All right, so go ahead and do that. Now, you do not need to copy down this table that I'm showing here, but I want you to look at it. This is the household incomes. This is a house, and this is for Alabama. So I'm going to put that. And I want you to write this in your notes. We're going to put Alabama household income. And this is 2018. I found this is real data that I found. I was doing something for grad school, researching. I was doing some statistics, education stuff, and I happened upon this just because I was like, oh wait, I got distracted and started doing a Google search for some data, and I found this, and I thought it was great. Now I could have gotten Tennessee's, but I had to pay $50 for that, so I was like, you know what, I'm just gonna go with the free version. Alabama's pretty close to us, like really close actually, so let's just go with Alabama. And let's talk about this. I'm gonna pause the video and I'm gonna ask you this question. What do you think the shape of the distribution for income, and not just in Alabama, because we have the data here, but in our country, what do you think the distribution is for just different states? Okay, so is it symmetric? Is it skewed left? Is it skewed right? Uniform? What do we have? So I'm gonna pause it and you answer. Okay, so now that you've answered what you think, we are going to look at this data here and we're going to actually graph the distribution. But let's first ask this question. Here we have household income in the past 12 months, and they break them into less than 25,000, 25 to 49,999, and the different categories. And then you have more than 250 or 200,000. Next question, follow up. Here we go. Is this categorical or quantitative? Okay, so you answered, you should have put quantitative. Now, let's not let that confuse us, because it looks like these are in categories, right? They've broken them down into sections. 1, 2, 3, 4, 5, 6, 7 sections that look like categories. However, this number, money, or any of the money values, it makes sense to find average dollar, right? Like that makes sense, and you've probably heard of that. It makes sense to take an average here. So that's sort of the more powerful way of describing this as quantitative, okay? Now, the idea that they've put them in these categories is to help with organization. We don't just want like values everywhere. That's overwhelming, okay? Because there's 1,860,000 households, okay? So I want you to go ahead and write N is equal to 1,860,269. And this is by far the largest data set we've ever considered in this class. But compared to like, well, and this is what statisticians do all the time. They use large data sets, okay? So we're not, we're gonna ask this question now. It's quantitative. I wanna graph it. Which one of the 4 graphs that we have and how we've studied is going to work here for this set of quantitative data? So you have dot plot, stem and leaf plot, histogram, and you have a box and whisker plot. So I'm going to pause and you're going to pick that. All right, so a dot plot won't work. Let's just start there. Dot plot is not the correct answer. Why? Well, we don't actually have the data. So the reason that I can plot these dot plots here, if I go to our data, here's a dot plot. This is the minutes commute to Stewart's Creek High School. It's because I have individual data. Can you imagine 1.8 million points on a graph? And typing all that in and having that data set? That's crazy. And I think it might break the calculator that you have. It might work on my computer, but these calculators don't have the processing power for that size of data. And definitely our brains don't either. So you got to have computer help for that. Dot plot's not going to work, okay? What about a stem and leaf plot? Well, stem and leaf plot is the most time-consuming plot to make, so A, it would be inefficient, but also same reason, we don't have the actual data, okay? So that won't work. Histogram. How does a histogram work? Well, we break it into classes, and then we draw the distribution. It's like that. It's all about frequencies within classes. Histogram is the right answer on this one. okay? They've already set us up to draw it into a histogram, okay? Why won't a box plot work? Well, box plot, you have to have all the data. We could estimate, I think, to make a box plot, but again, we couldn't make a very accurate one. The histogram is going to be the way to go on this one. So that's what we're going to do. We're going to create a histogram. And I promise all of this ties to what we need. So let's go ahead on your paper. I don't want red. Hold on. Black. And we are going to draw a histogram. Now we need to make 7 classes of about equal width. So I'm going to start right here. 1, 2, 3. That's not good. Hold on, let me move it over a little bit. 3, 4, 5, 6, 7. And that's just gonna 1, 2, 3, 4, 5, 6, 7. That's just gonna have to do. Okay. Then this is gonna be all of the income. All right, we're gonna say household income. What's gonna be up here? So we have 2 options. We have these counts. So do we want to make a scale that has 503,000 people or households? No, we don't want to do that. So we've talked about how percents are way better than numbers, pretty much always, because first of all, percents are more wieldy, I suppose is a way to put that. Like we're able to use them. They're only ever going to be between 0 and 100, and that's just easier to use, okay? So we have, up here we have counts, and here we have percents. We always want to try to use percents. Now counts have another word in stats, it's called frequencies. And then percents are relative frequencies. I want to keep using that lingo so that I need to make sure that you don't see a problem and you're just confused about relative frequency, okay? And know that it's percents, okay? So let's go ahead and start drawing this. We want to use relative frequency. Now the highest up here, these are decimals. So the highest percent is 27.08. So the most I need to make this is 30%. So we're going to go up by 5. So here's, we're going to start 5, 10, 15, 20, 20, oh no. 25, 30, and those are mostly even. We're going to put percent over here, and we're going to go 5, 10, 15, 20, 25, and 30%. So let's go ahead and start graphing this. This is less than 25K right here. So I'm going to go ahead and we start at 0.2708, so 27%. Draw a line over as good as we can. Draw a line up. Okay, there's my first bar. I'm gonna clean this up a little bit over here so it looks a little bit better, but we've got it. Oh geez. Let's do the next one. So the next one we need it to be, and I'm going to draw lines through here just to help myself out. If you have a straight edge, obviously that'll help you. 24.13, so about right here, straight across. Sorry for my OCD people, this is just how it's going to be. So we're going to erase there. Got it. Okay, so there's my next bar. Let's do the next. We need 17.43, so that's about here. Seems a little high actually. Let's go down a little bit. About right there. Okay. There. Up. Good. Let's erase a little bit, clean it up. And you should be drawing this as well. No. A little bit tedious of a process here, but again, this is definitely faster than doing it another way. Next, we have 11.47. Also, I need to be labeling these, so let's go ahead and put, what do you want? 25K to 50K. Then we want 50K to 75K. And this is 75K to 100K. I'm gonna go ahead and label all of these. I think the next window goes 100 to 50. So this one actually jumps a little bit higher, 100,000 to 150. Then it goes up another 50,000. So 150K to 200K. 1, 2, 3, 4, 5, 6, 7. So here's the seventh one. This is greater than 200K. All right, so let's go ahead and fill in the rest of this. The next one is for the 75 to 100K is going to be 11.47. So about, this is glitching a little bit. I'm gonna actually start using my mouse. So 11.47, we're gonna say that's probably here. Draw straight across. And then we are going to draw that up. There it is. I'm actually going to pause this just to make it go quicker, and we're going to I'll finish this up and jump ahead. All right, so like a chef on a cooking show, I have created my distribution, and you can now see what this looks like. All right, so there's a couple things that I want to talk about. First off, what is the shape of this? Does this match your prediction for what income would look like? Well, if you said skewed to the right, you'd be correct. Okay, you can. It's such an obvious skewed right because it starts up high. Most of the data is over here, and then it just gets lower and lower and lower. It's longer on the right side. And I'm going to go ahead and tell you, if we had Tennessee's data, it would look like this. If we had really any other state's data, we would have distributions that look like this, because the fact of the matter is, the people who make the most money, there's just not a lot of them. Okay, there's just not a lot of them. I had some slides. Let me find this. We have some money fact slides here that I want to share with you guys really quick. First off, this one right here. The average CEO has made more money by lunchtime on January 2nd than the average worker will make all year. So that's a pretty shocking money statistic. There's several more that I want to look at. Right here, the richest 1% of the world, okay, this is everybody in the world, earn 82% of all the money generated, and this was in 2017, okay? Now, to complement this, just so you're aware, you only need to make 33,000 US dollars per year to cut for the richest global 1%. So these sort of work in tandem. The idea, I am probably in this right here, just I make more than that, especially me and my wife combined make more than what this is saying here. So, you know, it puts a lot of perspective for actually how fortunate a lot of us are. And especially, you know, we have our parents who have good jobs. Not everybody's that way, but there's a lot of areas that are not as blessed as, you know, as we are for how much money we have. Okay. Now, you'll notice here that I left this blank, this median household income, 2018 income. So there was a reason I did that, because I want us to try to predict what that value is before I show it. So it is possible to get pretty close to the actual median value in here. Okay. So where would that median be? We've talked about finding the center of a distribution. Where's that balancing point for the distribution? And, you know, if you're thinking about that, that's helpful. But now that we have our definition for median, we want to use that. So if you want to flip back through your notes where we defined what a median was, you'll see what I'm talking about. So our definition for median was, it's the center point of the data where half is below and half is above. And then we wrote even clearer, 50% of the data is below and 50% of the data is above. Okay, so I'm going to go ahead and label these. Don't do this on yours. This is A, B, C, D, E, F, and G. Okay, this is going to be a multiple choice question. So I'm going to ask you to answer this. Where do you think the median is based on our definition? It's going to be somewhere in one of these categories. We don't know the specific value, but it's going to be somewhere. So A, B, C, D, E, F, G, tell me which one you think it is. All right, so let's look at this. If you answered this and you weren't really sure, but you maybe you got it right, let's talk about the thought process. So first off, I know that what percent of the data is in this first one here? Well, that's 27.08%. How much is in the second one? That's 24.13%. How much is in this one? 17.43%. I don't really need to go on, okay? Because based on our definition of median, where half the data is below and half the data is above, so we say to the left or to the right, half is to the left, the answer should be B. So think about that. If I add up, we start adding these histogram values up, 27.08 plus 24.13, we get to 51.21% in these first two columns. Now, why do I know it's not A? Well, A only comprises 27%. So Q1 would be in here, okay? Q1 is going to be in this one, but the median is going to have to be in this one. Now, if we had to guess, is it closer to the beginning of that or the end of that? We would have to say the end of it, because look, 1.21% is all that remains on the higher end of this bar on the histogram. Okay, so it's somewhere in the upper end of the $25,000 to $50,000 value. And I actually am going to share with you what that data actually is. So I'm going to here's the data sheet that I had. I made this blank here, so I'm going to reveal that number now. There it is, 48,486. This is a specific value. This is how we know that they have the data set, like they have the list of values for the census, is because they have an exact value. Now, we were not able to actually find an exact value because we don't have the list of data. We didn't know, but we were able to approximate. So we're going to go ahead and put in this value, 48486. So we're going to put that 48486 is the median value of this distribution. Okay, so I'm going to erase these real quick. I'm going to ask this question, the mean. You'll notice that, I'm going to go back to this data set here. You'll notice that they don't put the mean anywhere, okay? They don't use mean in any of this. So let's think about that, okay? Why would they not use the mean to describe this income, okay? Why would they not do that? Let's imagine that this is in Oregon or Washington or wherever Amazon is stationed, and let's put, I'm going to draw a stick figure over here, and we're going to call this stick figure, hold on, let me make sure you can see this. We're going to call this guy Jeff Bezos. Right? Everybody should know who Jeff Bezos is, and I think that coronavirus quarantine and all that have gotten him more wealthy than before. He owns Amazon, if you didn't know. And if he's on this distribution, he obviously would fall in this category, but he is so rich that we almost imagine him being so far like up, right? He's way over there, okay? So if his actual number is in this category, he's like way up there. He's by himself, right? He is like the pure definition of outlier, okay? And if we calculate him into the calculation of mean, adding all the values up, dividing by the number in it, he is going to ruin it, right? His value is going to absolutely drag everything up. I want to show another cool money stat for you guys. Money fact. Kind of a sad one, actually. Here we go. The cost to end world hunger would be $30 billion a year. This is the same amount as drunk Americans spend online annually. So yeah, Bezos is making tons of money annually on Amazon, and apparent, according to this statistic, this is, people they just shop online when they get drunk, okay, and they're impaired. Here is actually a Jeff Bezos. That's what he looks like, by the way. He has enough money to buy everybody in the world a Big Mac. There's over 7 billion people in the world, and he has enough to purchase everybody a Big Mac. Okay? So, interesting perspectives on money that we're gaining here, but we do not use this for, so do not use for money distributions. So this is because of outliers, right? And we know this. Where would the mean actually be on this if we had some of those high outliers, these people that are causing this value to be pulled this direction? Well, the mean is probably going to be like over here somewhere. So this might be X bar right here. Okay? When the median is actually back here. And that's a better representation. So think about it. And I want to give you all this perspective. Over 50% of this distribution of Alabama households make less than $50K a year. That's crazy. Me and my wife make more than that, so we're not in that category. And a lot of you won't have to make that little amount of money. It just depends on, the decisions you make. But again, that's all about habits, and, education helps you build wealth. But it's crazy that half the population makes less than that, right? The median household income is $48,000, right? So a lot of you are think that maybe one day you'll strike it rich, and you don't have to strike it rich. If you put this into perspective, if we kept going, we add these percents up. So let me add those a little bit more. So plus, let's go 17.43 plus 11.47. 80% of people make less than $100,000 household. Okay, I can tell you that I'm in this 80%. All right, and I am happy. So I want you guys to just keep thinking about this data. This is 1.8 million. It's humongous amount of data that's really showing you the reality of how money is distributed and how it works, and giving you some perspective. So the real, this is to teach stats, but it's also to inform you guys about like how much money you could potentially make one day. And if you were expecting to be this, $1 million a year salary, $100,000 a year salary, whatever, it's rare. It's not easy to do. It's possible. It takes a lot of work, and but this is just to like inform you guys about that, but also talk a little bit about how to describe centers for these distributions. Okay, so the reason we don't use X bar is because of outliers. All right, this was a long-winded spill, but I think that it was a worthy example of your attention and time. But we're gonna go ahead and write down some notes. Okay, so for center, for skewed distributions, use median. Box around that. Okay? For skewed distributions, use median. This is due to extreme values and outliers. Next, for symmetric distributions, use mean. Okay, symmetric distributions use mean. We've discussed why. We see why. Now, For similar reasons, now we're going to talk about spread. So our measures of spread are IQR and standard deviation. So spread. So which one would be better for a skewed distribution? Would standard deviation be good for skewed distributions? Well, think about this. How do we calculate standard deviation? It's the average distance to the mean. Okay? If I add Jeff Bezos into my deviation, he is so far from the average that he's going to mess up my standard deviation. Okay, that should make sense. So we won't want to use standard deviation for skewed distributions. So for skewed distributions, we need to use IQR. So we're going to say skewed distributions. Use IQR. This is due to extreme values outliers. Next, for symmetric distributions, use standard deviation. These are test question ideas, okay? So you will have test questions that say, what would be an appropriate measure of center and spread for the given distribution? You need to identify the shape, and then you need to say which one, okay? It should be obvious. I'm not going to put something where you're like, I don't know if it's roughly symmetric or if it's skewed. I don't know. It's going to be super obvious that it's skewed or that it's symmetric, okay? If I put something that is not that way and you have a question, you can obviously ask me about it. And if it's graded wrong in some way, you can talk to me about that as well, okay? I had planned, so I'm through, we got through what we needed to. So standard deviation questions, choosing measures of center and spread we got, so that's good. So putting X's on those. But we're already 32 minutes in. I'm gonna make one more video tomorrow morning and get that uploaded because these are taking longer than I had anticipated, but I think that this was a really good example for you guys to look at how these distributions for wealth are created. I think money is always an important topic. Everybody cares about talking about money and understanding how the world of money is and finances and how they go. So I don't feel bad about going through that with that much time, but I'm gonna stop this video here and we'll have one more lesson to finish this up. I'd hope to get this all done in one video, but it's just too long. So I'm gonna stop.